Good evening, everybody. You can see my screen, I take it?
Yes.
So we're going to talk about just a couple different things about Azure. I'm an Azure consultant, also in the security, identity, and access management space. So I do a lot of different things with the Microsoft technologies in the cloud and on-premise. Azure is a huge topic. So we wanted to talk about infrastructure today, and I'm really not going to cover everything infrastructure because it's impossible in even 4 hours to cover all the different aspects of Azure infrastructure. So I picked a couple of ones that are near and dear to my heart, which is networking and some of the things in networking that people just don't touch upon. As a consultant, I go out to customers, or well, now virtually go out to customers and see different things. And there's some things that I think people are missing and not aware of inside of networking. So we're going to talk a little bit about that, storage and how that comes into play, backup, and then ASR, the Azure Site Recovery. All of those kind of fun topics in about an hour. So let's first talk about, as I mentioned, networking. The first thing is a VNet, right? So an Azure VNet is really the basis of everything. That's the fundamental starting block of our environment. So Azure assigns a resource in the VNet, typically in a private address space. I've never seen them do any other way, but they can give you public IP addresses for different components that we'll talk about in about 4 or 5 more slides. But the VNet is going to be in a private address space. So it's going to be somewhere, I mean, maybe like in the 10 range. A lot of times it's 10 with a 16 subnet mask. And then your individual machines would be 10.10.04 or 10.0.0.4, etc. in that same range. Much like you would have traditionally on your internal spaces today, right, behind firewalls and other things. So what happens is the VNet is configured, and like I've already said, the 10 address. I really don't see too many other than the 10 address, though it is RFC 1918 compliant, so it could use the 172, the 192, but a lot of times the networks just start out with 10, at least for your bigger subnets before you break it up, and it really depends on where your tenant is configured. So the tenant is the overall architecture of the thing that you're paying for with Microsoft and Azure. So that if it's in Europe or if it's in Asia or Africa or the United States, somewhere in that address range, you're going to get that. So those are the different regions that would be then scoped out, and they have different subnets for those different regions. And then you can also take the VNet down to the subscription level, which is a smaller component of the tenant. Okay, so once you've got a virtual network and you've got an address space, what we have is NSGs. And NSGs are fun. That's the network security group. That's where we're really going to break everything together and filter our traffic. So this is kind of a firewall component for a lot of customers. This will help you with your in and outbound traffic at a port level. Typically, you don't want to use an asterisk or an any there. For whatever the protocol we're talking about. And we can do this by subnet. We can do it by IP address range. We can do it by application. There's lots of different ways that we can do the NSGs. But they're very, very important. Now, I've had customers, a couple of engagements ago, someone said, I don't want to use any NSGs. It's just too complicated. We've already got a firewall. I really don't need to use NSGs. I don't need to get that detailed in my application to break it down to the port level for the inbound traffic for this subnet or subscription, right? And that's really not true. If you have the capability, and especially if you're doing like a web publishing, a web service ASP, so we've got a web app that we're going to publish out there, and we're hitting the web server, maybe a virtual machine that has a web server on it, Docker, doesn't really matter, right? And we're going to get that. We can just say, you know what, the NSG just let 443 in and still block everything else out. There's traffic inside of Azure, inside of our own VNet from the previous slides, that are still going to bounce around, and we may not want that to be seen or get through. So I strongly recommend that you still use NSGs. Maybe you make it a little bit more open, so you give a little bit wider port range, but you still block some traffic. right? We don't have to have any traffic or all traffic going to all our different components inside. So network security groups is the lowest level that we're going to block that at. We're going to see as we progress that we're going to block it at other levels too. So how do we get to our Azure cloud space, right? So we bought a tenant, created a subscription, doing some things. Typically, you're going to use one of three different ways. So a VPN, a virtual private network, that is going to be encrypted traffic that's going to go over our public interface, public network, right? So it'll fly on the interwebs with everything else that's out there, right? Someone searching for Google, chatting, this Teams meeting, our VPN will travel over that same network, but the packets are going to be encrypted. Some customers don't want to have that bandwidth allocation and potential problems. So what could be a problem? Well, maybe I start streaming a whole bunch of video on this channel. So I start streaming a bunch of video. We're going over the same public network. We're using the same internet service provider, ISP, and now I'm chewing up more of the bandwidth. Let's say that they don't have any way to allocate more bandwidth or segregate it, right? So what happens? Now our VPN could slow down. It's not getting enough bandwidth. So what they came up with is an express route. Now this does not work to every country. You can't do this in China. So this is something that you purchase from Microsoft. You will buy an express route from them that says, you know, I just want to go from here to there. And the here is typically your on-premise, maybe your MPLS. And then you're going to hit a private dedicated connection that's still encrypted and all that fun traffic and extend that into the Azure space. So into your tenant or tenants and subscriptions underneath those. So an express route is going to guarantee our bandwidth to an extent. We're not going to have to share with the public. No one's going to be able to see the traffic. Okay. And it's a great way to connect our Azure services. But again, it doesn't work everywhere. And not all providers will allow you to do that. Like I said, China is one of the ones that Microsoft does not have an agreement with. So there's no express routes going to traffic to China. So if you had an office, so if you wanted a global environment and you had an office in China, you would not be using an express route from there to get to Azure. It's just not allowed. So you can also combine those two things. You can combine the express route with VPN and have the VPN as a failover, right? So you could have your dedicated connection with an express route, and then if that were to have a problem or go down, then you could have your VPN connection as a failover, okay, in case there's a loss in connectivity or the circuit goes down. So what is VNET peering? Again, another hybrid connection option with Azure. So you can see that we have our on-premise network. And in this case, in the example in the slide, I put that we have a express route circuit, right? So we're not doing a VPN in this point. We're just doing an express route circuit. We are going to try to offload and just get to certain workloads. So here we can narrow down the traffic to maybe a specific data center or data centers, but not to everything. To subnets in the data centers. So if you have a data center that, and some customers do, that have the server address space in it, but they also have client address space. I don't think I need to have my client address space to be peered or VNetted into Azure directly. They're going to get it through a web interface typically, or go through a VPN. Or talk to the application locally. They're not going to need to go from their client machine. I want to do this for a couple of reasons, right? If there is some kind of outbreak or an infection on the client machines, I don't want that network tied together to my Azure cloud network. That would not be a good idea. So I can segregate traffic between my data centers by subnet and send it to the Azure cloud. And I can have multiple VNet peerings within inside my one express route circuit. So I could have one from my data center. Let's say that we have an East and West Coast data center. So we have my East Coast data center. I could have an express route from each one. And then, of course, VPN failover for connectivity issues in case there's any droppage. And then within that, I could have as many VNets that are peered as I need. So it really allows you to overcome limitations for things like subscriptions and going to a central hub. If you want to centralize your IT for certain componentry, so in other words, you have your monitoring solution that's on premise, I could VNet peer that into Azure monitoring and not let any other traffic through there. So I can really segregate and control my flow of traffic with VNet peering. It's a very good solution, and it's all just traffic. So it depends on what you're using there on the cloud. It doesn't really cost that much more or anything. As you are probably aware of, you look at Azure, you're paying a service, but we already have an express route that we're paying for that has my full connectivity as the packets flow through, depending on the application and what we're using. If we're using Azure logging, analytics, etc., then we're going to pay for that, but it's really not that bad. So now this one is kind of fun. So a lot of times customers are used to doing Azure load balancing on premise, maybe F5, Big IP. They're using some kind of load balancer, Cisco load balancers, a lot of different things that they can use to do load balancing of traffic. Azure has the same thing. They have virtual appliances that you really don't know that are virtual appliances out there. They've just got a interface called the Azure Load Balancer, or just LB is what they call it inside the Azure product. So a load balancer, as you can see here, we're doing something that I would not recommend, but it's for example purposes only. We're putting port 80 on the internet. Really not a great idea, but for example purposes, let's see how that would work. The load balancer is also packetized too, kind of like the NSGs that we talked about, the network security groups. I'm not going to let everything through. At the load balancer, the public load balancer, which is this one right here, the top interface, I am going to only let in port 80 in this very poor example. I really wouldn't recommend doing port 80, but we're doing that on purpose. So we let in port 80, we get to our web tier, all the VMs are answering on 80, life is good, but they need data. So they need to go to our database tier, and there's various models of SQL that we can have out there. We're not going to get into those in this presentation, but we've got some kind of SQL back there, and it's coming from more than one spot. It could be because it's table or data driven, and maybe we need to combine things from multiple sources. So we're going to have an internal, an ILB, an internal load balancer. And that internal load balancer, again, is going to have port rules too. And we're going to let TCP 1433, which is the default port for SQL data. So we do have secure access from the VMs out to the internet. We're not doing any kind of level of encryption in this one, but for example purposes, we do have the capabilities of having port 80. Now, again, in the real world, I wouldn't recommend doing this. You could have the public load balancer answer on port 80 and convert it to 443. You can do that with the load balancer too. So you could load up a cert on there. Also allow, just in case somebody forgets the S when they type in the URL for this application, that it would then translate it into 443, give it encrypted at the web tier model, and then still use the internal load balancer, the ILB, to hit it on the inside at TCP 1433 or whatever ports are necessary for that. So very common to have a load balancer behind a load balancer with some traffic in between going to something in the multi-tiered model. Real big fan of load balancers, and they're basically free. It's really not a bad cost model. You don't have to worry about firmware updates like you did on premise. You don't have to worry about any of those things because Microsoft's managing everything for you. So it's really kind of a nice process for you, and they don't really go down. It's fast, it's efficient, and it works great. You can put whatever you want behind it. We're just putting VMs, but you can put whatever you want. Could be any instances of anything else. Now, I would strongly recommend, and a lot of customers don't do this. You'd be shocked at how many engagements I get where they don't have a firewall in the cloud. And the discussions I've had with SecOps is they say, you know what, Microsoft's maintaining it. It's a private network. We talked about the VNETs, that it's going to be in the RFC 1918 address space, so the 10, the 172, the 192 address space. So I don't really need a firewall out there. Really? Seriously? We don't need a firewall today, even in the cloud? So malicious packets don't get through. Our application, in the previous example, for crying out loud, we did port 80 out there. That's really secure. So now our VM gets compromised on port 80. There's an injection on there. Maybe it passes through with a SQL injection. And we've got malicious code running out there. Now that we don't have, because if we didn't have a firewall, guess what happens? we can have unfederated access within that Azure cloud. Even though it's in the private address space with the 10, it can start to bounce around with what permissions and what it has. So it's really not a great idea. Strongly recommended to have Azure Firewall, at least for egress, to make sure that we're understanding where things are going, right? VNet need to get everywhere. And it's very common to have a hub and spoke environment for all the different VNets and to possibly have several firewalls depending on the implementation and how we're doing the traffic. We might have a firewall going from inside of the Azure cloud outbound, and then again also back in through our VNet peering to on-premise through our express route. So very common to have it in multiple directions. And then it also gives us the capability, when we have an Azure firewall, to segregate traffic, right? To look for different things, like in the slide it talks about malicious IPs and frequently qualified domain names and service tags and threat intelligence. There's a lot of intelligence inside that's a layer 3 to 7 for the user policies and connectivity. So we can have connectivity rules, we can have port bound rules, we can look at the packets intelligently, we can make sure that someone isn't trying to go a route that we didn't expect from our application. They came out from the internet and then they're going bouncing around to another server. That is not what we wanted. We wanted them to go back to the client, back to the initiating process, egress traffic only. So we can control a lot of that. And maybe we don't want it to leave that subnet for that application and ever to go back on-prem, right? So the Azure Firewall can allow us to do that. The other thing that we can do is we can build a DMZ, demilitarized zone, right? So now, once we start putting some of this technology together, we can use a concept called an NVA, which I'll talk about in the next slide. That's the virtual appliances, and the marketplace has a bunch of those. So what we've got on the slide, if we got on-premise, we've got the internet. They're all coming in. We can segregate the different traffic into a management subnet or VNet that has that traffic on that. We can have a private and a public VNet. So the on-premise traffic would talk to the DMZ VNet that is coming from on-prem and segregate that traffic and make sure that anything that's coming from the internet is stuck in its own little enclave, right? So we have a public DMZ or demilitarized zone. Typically in between all of this, which the slide would be a little bit too busy, you're gonna have load balancers for an HA solution or high availability solution. So you're typically not just going to have the DMZ and talking to your web tier or other things. You're gonna have some other componentry in there. Right, so we put some stuff together, but I was trying not to complicate the slide with showing you the full path. So this isn't exactly a how-to build diagram. It is more of let's talk about the DMZ.
Hey, Rodney.
Yeah.
Hey, there's a question in the chat. I don't know if you're able to see it.
I can't because I'm in presenter mode. So yep. Thank you for letting me know.
The question is from Scott. He's asking, would you still recommend having an Azure Firewall for a serverless environment, or would you use another product?
So we're going to talk about, you could use another product. That's exactly what this slide, that's a great lead into here. So they both work. It really depends on your skill set, right? So if you've already got your security team or the team that manages your on-premise firewalls or any cloud-based firewalls you have for Azure, for AWS, for Google, whatever you already have, if you have a network appliance vendor that you like, whether it's Palo Alto or Cisco or somebody else, and you have that knowledge set, then it's very common to not use the Azure Firewall and replace it with a network virtual appliance that is single task for firewall, if that makes sense, right? So we want to have some kind of protection out there, and whether it's an NVA, the network virtual appliance, or the Azure Firewall is simplistic and it does everything, but again, it's another discipline. So you have to start looking at all these different Azure components and decide, do I really want to learn something else? Or would it be simpler to go to the marketplace and either pay as you go or bring my own license that I already have? Because maybe I already have a license for more Palo Alto, so I put those out there and I already know how to manage that, right? So I can connect to the web interface of the Palo Alto inside of Azure. That's my Azure Network Virtual Appliance, and then configure that. If I'm going to go that route and I have that skill set, then no, I would not have the Azure Firewall. If I don't have that skill set, or I don't have a license, or I don't want to pay as I go for that virtual appliance, then the Azure Firewall is a great option. So it really depends on skill set, timing, and complexity of the environment. And if that doesn't answer the question, then just let me know and I can go in a little bit deeper. So as I've already mentioned, we've got these virtual appliances out there. They're single task. Now, the one single task I just mentioned would be that it would have firewall, but it could be for application delivery. It could be for WAN optimization. That's very prevalent. Again, to go through our express route and peering, get back onto on-prem, give us optimization for that traffic, whatever that traffic may be. Typically would be something like a video streams through Azure. If you're going to go that route, that's not a bad thing to have, is have a virtual appliance for that. It could just be routing, right? So we have in the slide, it talks about a user-defined route with coming from on-premise. User-defined route, sorry, is user-defined route is UDR. So that's what I'm mentioning there. So user-defined route is a route that we have specified from inside of Azure. So you're going to have some default networking when you set everything up, your VNets and subnets, but then you can also put in your user-defined routes to get from point A to point B. In this case, we've got the same slide that I used for the DMZ one. So we're trying to get from on-prem to the private DMZ, and we could have a UDR. We could also have a NVA in between there to help that routing traffic and to guarantee packet flow. And also easier management, right? So we can look at the single pane of glass, look at all the management of our MVAs if we have extended the pay-as-you-go model for, as I mentioned, like Cisco or Palo Alto or someone of that nature. So there's a lot that we can do with MVAs. Obviously, the marketplace, Azure has this thing called the marketplace. It's called the Azure Marketplace. A lot of things in Azure are called Azure something, but we'll just call it Marketplace for this. And that would allow us to see the different vendors, and we can sign up and get a 30-day trial and look at some things, kick the tires, and see what's going on. Okay, so now this is one that I don't see a lot of customers using, and I want to make sure that you're aware of it. This is really big. I have helped out multiple customers that were putting out applications out there. In the slide I show you, there's an image service pool or a video service pool, but I've seen this for web applications, publishing different data sources. I had a customer that was doing SAP internally, and then externally they were, it was a military that was trying to do an HR application, so it was part of the U.S. government military, and what they were doing is the HR people had to put in with the National Guard got deployed, they had to put in overtime pay. So they would do the overtime pay, but they only had a subset of that. So there's a small interface. And what we did was application gateway with a WAF, which is the web application firewall. So this is another firewall. So this is the third firewall we mentioned inside of Azure, right? We talked about the Azure firewall, we talked about NVA, and now we're talking about the application gateway, which is a layer 7 load balancer. So we're really combining a lot of the technologies that I've already mentioned. We're talking, you can turn on the firewall. You don't have to turn on the firewall. And we're doing this from an application level standpoint. This does have affinity. Affinity is where you'll do sticky sessions and cookie based. So if you have multiple entities behind the application, so in the National Guard one that I was talking about, it was an HR application. They had multiple Docker web servers that were out there running Linux and running a flavor of Linux. And we did a load balancer in the front, and we did a load balancer on the internal, an application gateway load balancer, I should say, to the SAP application so that it would do the nightly feeds to get the data back and forth. So it was just kind of a stopping point for the application. So what's nice about this is everything's managed through the Azure API. It's a complicated but not that bad of a setup. It walks you through, just like most things in Azure, there's a next. You can do this with Terraform or automation, Azure DevOps, and then deploy the whole thing. So the application gateway, what I like about it is it's highly available. It's, again, a virtual appliance that's maintained by Microsoft. They claim that it's 99.95% uptime availability. You can have certs inside of that. You can also do termination of cert certifications, SSL, right? Or you can pass it through, or you can change the certification. Right, so we could have an external for our widget.com application with it, so it's widget.com on the outside, but then inside, which is what we did for the application that I mentioned before in SAP, that had a different certificate for the SAP servers. So we translated, went from 443 with widget.com on the outside to something.sap. Whatever it was inside with another SSL cert and hitting that application gateway / load balancer in there. And again, as I've already mentioned, you can customize this whole thing and also turn it on and make it an application firewall, right? So you can have another firewall. So we could still have our outside or inside firewalls behind all this. This is typically one of the outer facing componentries that you're going to have inside of Azure. It's kind of confusing, right? So it's inside of Azure, it's inside the Microsoft cloud, but it has an external public facing IP address if it's a public facing application gateway / load balancer / application firewall. So typically it's just called an AG, but it's really all of those things, right? It's going to load balance, and it doesn't have to load balance. This is what's nice about the application gateway. If you're single threaded in your application and it is not a load balance application, in other words, there's not more than one component behind it, right? You have no HA, no high availability. You only have one thing. You can still use an application gateway. The load balancer is going to be upset because it's going to fail a health check and only have one thing. It will still function, but it's not an optimal use of a load balancer. You don't typically put a load balancer in front of one thing. It's like clapping with one hand, right? When you clap with one hand, there's no sound. An application gateway does not have a problem with you clapping with one hand. You could put one thing behind it. And the one thing behind it sometimes is another load balancer if you have a DMZ. So again, we have a public IP address on the application gateway that points then to a load balancer. The load balancer, it doesn't have to because it can do the load balancing in the AG. But sometimes customers will do that for the DMZ. They want to keep everything through the load balancer traffic and not have the AG just go around it and go right into the DMZ. Again, you'd have to look at your design and decide what makes sense for your organization, but that's very common. Right, one of those two scenarios. So we can have an application gateway, and maybe it's load balancing the traffic, maybe it's just sending it to the load balancer, who's doing the health checks. As you can see, we've got public, private, hybrid sites, so we can put this internal, and there's just, I could go all day on the application gateway. There's a lot of feature functionality and a lot of use for it. Maybe I don't want to have the complexity of going from the internet through a load balancer, and maybe I don't want to publish my load balancers external IP address publicly. The AG can handle that, right? So I can do SSL termination, public IP address, and then I can get rid of the load balancer if I don't need it and use the application gateway as a load balancer. So there's a lot of possibilities here, but it gets even more fun if we go back to the scenario where I mentioned where there was East Coast and West Coast. We had different data centers. So now they have this thing called Traffic Manager, and this is where we tie everything together. A traffic manager is really just fancy DNS in the cloud. So now we have our widget.com, which would then point to Microsoft's traffic manager, and it's all DNS resolution. I'll go over those first four components in a second. So it's fancy DNS resolution to figure out the rules that we have set, and there's seven different ways you can do this through Traffic Manager. I could say that if you're coming from an IP address range, I'm going to put you to the East Coast, or I'm going to put you to the West Coast, so I can try to give you smaller RTT, the round trip time, for your packets, and guarantee that you're going to get delivery in a quicker fashion. I could load balance it and just say, you know what, first one comes in, goes to the east, next one comes in, goes to the west, and we're going to try to keep the information flowing in both directions, but not really caring about their RTT or how packets are flowing from that standpoint. We can single thread it and just say everything goes to the East Coast unless the East Coast is down, and if the application gateway that's behind this is down on the East Coast, there's an outage, or maybe we're doing maintenance, then 100% of the traffic goes to the West Coast. Like I mentioned, there's a lot of different ways that we can set up the rules to the traffic manager, but the key thing that I want you to know here is the traffic manager is not doing anything with connections. It is literally just a broker that is functioning as a DNS component. So it is literally just DNS traffic and trying to do some fancy things in the background and using those rules that I just mentioned, however we set that up to do high availability or to segregate traffic or to have in more of a disaster recovery scenario. There's a lot of different ways we can do the traffic manager. It's pretty slick. It doesn't cost hardly anything because it's not doing any traffic. It's literally just fancy DNS. So let's go through this slide because this is where we kind of start to tie everything together that I just mentioned. The application gateway, that's also a load balancer, that's also a firewall. Behind that, we have other componentries, maybe more load balancers and firewalls and other kind of fun stuff too. So the traffic manager, in number one, we start up here in the top. We got user that's using a browser, right? So the client sends a DNS query. So in this case, let's say they're trying to get to something like, I don't know, partners.contoso.com. All right, so they're trying to get to partners.contoso.com. A recursive query gets hit. It's also called a local DNS service. It does not host DNS, that domain. It does not. The traffic manager does not have access to the local DNS, so contoso.com. So what happens is the client offloads some of the work for contacting the various things itself across the internet using name resolution. And step number two, after it's typed in partners, what happens is to resolve the DNS name, recursive query kind of finds, hey, where's contoso.com? That is the domain name that's underneath partners.contoso.com. And what that points to, so we own that record. That's inside of our namespace, we're contoso.com in this example, but it's going to point to contoso dot, you ready for this? Trafficmanager.net. That is the Microsoft namespace for Traffic Manager. So we've typed in partners.contoso.com. It is now getting resolved to contoso, our domain name, .trafficmanager.net. Then there's more DNS traffic in number three, going back and forth in three and through five with the Traffic Manager service at Microsoft. So another recursive DNS service, our name server inside of Microsoft, goes to trafficmanager.net domain, which are provided by the whole Azure service. That's what you're paying for, is them to resolve some of these things. Right. It then sends a request to contoso.trafficmanager.net to record those DNS servers. Now, what is it doing? In step number four, the traffic manager, the name server that's now receiving that request, is going to try to figure out how I'm supposed to route the traffic. So the traffic manager says, what are the rules? So the first thing is it's going to look for things like configured state. Is the endpoint up or down? This does not depend upon your traffic flow. I mentioned previously, if we had an east and west coast, the traffic manager is going to try to figure out, is the endpoint disabled or not responding, right? So we've got health checks going on in the background. So our east and west coast both up. The next thing is if they are up, what's the health of it, right? Are they responding to a 443 request to our probe, right? Because you set up an HTTP, typically in a web application, you would set up an HTTP, not an HTTPS, HTTP probe, so you can get back the proper result code. So to do what's called a health check inside that process in that probe. The third thing it's going to do, it's going to then look at our routing methodology, as I mentioned before. Is it going to do 100% load balancing to East Coast? Is it going to go round robin back and forth? Are we going to do IP address range? Are we going to do something else in there? There's a lot of different ways we can do that, but it's going to then use that methodology. Notice the first things that it did, though, in the first two steps is it up? Is it healthy? Right? So there's no reason to start doing routing if it's not up and it's not healthy, because that's not going to work very well. In number five, now that we have gone through all that criteria, the chosen endpoint is returned with a DNS CNAME record. Now, what's important here is we're going back to that original client and giving them where we found. In the example on the slide, as you can see, we found that we're going to Europe in this case. We're going to eu.cloudapp.net. So that is the server. I use that term loosely. It's probably not a server. It's probably an application gateway, or if anything, a load balancer that it's returning So there's more than one entity behind that, right? So we've got the traffic manager that's routing the traffic in the cloud through DNS, and now we're going to be routing to eu.cloudapp and then .net, and then that's going to go to individual servers in that farm that it's got underneath there. Okay, so then in step number 7, we're going back to the client with the recursive DNS consolidation to return that single DNS response. Again, that single DNS response could be the load balance on the, in this case, we're going to Europe, the European zone, because that's what the rules had figured out. Maybe we're doing it by continent. I'm not really sure, but that's what it's figured out where we need to go. The client then uses that and does a connection. So the connection is going to go to, as I mentioned in the slide, Contoso EU, right? It's going to go to the European site. It is not going to go through the traffic manager. By the time we get to this point, the traffic manager is already done. By the time we get to step 5, the traffic manager has already told you, all right, well, I know who's up. I know who's routing. I know who you should go to. You go to this. Here's your resolution. Go get the traffic. They would do an HTTP GET or request to get the login page if it's a web application, and continue on there. If it's a HTTPS application, which it should be, it'll do SSL or TLS, do that handshake and continue on. But it's not going through Microsoft's traffic manager at that point. We're done by the time we get through step 5 with that information, and we go from in point 8. You can see the browser kind of connects directly to the web application. So we're tying a whole bunch of things together with the traffic manager. I'm a real big fan of that. It's been out there for a couple of years now, and it's a good product. I like it. But it's just DNS. It's fancy DNS, and there's a lot of DNS, but it's really just DNS. And that's going to handle everything. We're going to have application gateways on the East and West Coast. Recommended that we have application. You don't have to, but you can just have LBs, but I wouldn't do that. Okay. Azure Storage. Let's talk a little bit about that. Okay, so what is Azure Storage? We got a lot of stuff going on in Azure Storage. Microsoft tries to give you a lot of flexibility. They have a storage viewer that you can go out there and look at all the blob data and see how things are going, obviously with access controls and permission and RBAC controls on those. But we have blob storage, file storage, table storage, queue storage. They've got a lot of things. We've got managed, unmanaged. We can have it scalable. It's we have various ways to get to this storage. As you're showing the slide, it's .NET, you got Java, you got Python. There's a whole REST API, which is very popular. There's a lot of different ways that we can get there. As I mentioned, there's also a storage viewer. We can use PowerShell. For the most part, everything you can do in Azure, you can do from in PowerShell, as I mentioned. And you can also use the command line interface or Azure CLI to get there. So there's a lot of different ways. I'm a visual person. I don't want to use the web interface all the time. So the Azure Storage Explorer, that's a good one. I really like that. It works out very well. I can traverse down kind of like you do Windows Explorer. It's not Windows Explorer, but it's the same concept of Windows Explorer. I do have to authenticate to Azure into my tenant / and then each subscription that I want to go into, and potentially each blob underneath that, depending on my RBAC controls, my security there. But it works out great. So that's an overview of it. Let's talk about the different storage types. So what's a blob? Right? It's massive. It's scalable, and it's object. Okay, it's a binary object is what it stands for. So that is our blob. We also have Azure files. As I mentioned before, everything has to begin with the word Azure. So we got files. Same thing you would have if you had on-premise deployments. You have files on storage types. We could have those same things in the cloud, also, and have shares of those to have typical file shares. We also have queues. Okay, so if you have applications that need to do messaging back and forth, we can have reliable messaging application queues, right? So those components can talk there. We also have tables. So Microsoft wants to make sure that you don't have to have SQL Server to do everything you want to do. We can have tables to score things, and we don't have to have a schema for that because it's not SQL. It's called NoSQL, NoSQL. Okay, but it can still be structured. So we have the Azure tables. And then we have regular disk storage, right? These can be managed. So managed means that Microsoft's going to handle that area for you. right? Same thing you would do with physical disks on premise. It's pretty much the same concept there. And we have different tiers of those. And we can do all the same types of stuff, but Microsoft or Azure is taking care of all those different components. So we have two main levels of getting access to the storage. We have the storage at the account level, and we have it at the container level. So when we're talking about at the account level, you can either use storage by account keys to get to that by your account, or you can use a shared way of doing that, which is a SAS or a shared access signature. And that can give you more granular access inside the account level access to storage to get to all the components that I mentioned before, the container, the table, the queue, the files, etc. Right? Those are all there. At the container level, again, we can use SAS keys, or we can provide public access at the level of the containers. Not as prevalent, but it is popular. So you typically want to use private access level, but you can use unauthenticated users access with public, right? So underlying blobs. It is a feature. Not always as prevalent or as popular, but it is way. So unauthenticated users, if we have the private turned on, if we're using public access, they're going to get to it. But if we have private access turned on, they have to be authenticated, right? So if they're not authenticated, in other words, they're unauthenticated users, then they won't have access to any of the data like the blobs. So what kind of data protection do we have that? We have data at rest that's not moving, and that can either be at the client side or can be on the server side. So the server side is called server-side encryption. So we encrypt it at the server, right? So it's sitting there on the server, it's stored, it's encrypted, or we could have it on the client-side encryption. By default, though, everything in Azure is encrypted for the most part, especially your data at rest. So that is the default. That is a good default. I haven't seen a customer turn that off yet because they want that. It's all seamless in the background, depending on the previous methodology, how I mentioned how you get there. And then in transit, right? So typically you're going to do this through HTTP or HTTPS, more than likely HTTPS. You can configure that they have the web interface, or as I mentioned before, PowerShell, Azure CLI. There's various ways to do that. So we can figure out how we're going to do the in transit, right? Are we going to encrypt it in transit? Well, not everybody does that, depending on the path, right? So if we're using an Azure firewall or an MVA and we've got encrypted traffic anyways, or we're only staying within the Azure cloud and that's encrypted, then we may not need to do any encryption in transit, especially if we have it at rest. So yeah, you'd have to look at your application and decide which makes most sense for you. So we have a couple different ways to do the encryption at the storage level. We have LRS, ZRS, and I've got several more on the next couple slides. So the local redundant storage is the lowest level. I'm going from the easiest, cheapest on up to the fanciest, more expensive as I go through this. So the LRS is the lowest level. It's the cheapest. It's not that durable, right? If a data center has a problem, something happens, all the replica and all the data will be lost because it's the first word. It's local. There's only one copy. It's local. It's in just one data center. So if that data center is gone, then I have a problem. So if you don't like that, then the next one we have is zone redundant storage. So now Microsoft will replicate your data across 3 different storage containers in a single region. This is important. So a single region. In the previous example, a couple slides ago, we talked about Europe, right? So if this was a zone redundant storage in Europe, I would have 3 copies in Europe. But if Europe is down for whatever reason, I have 0 copies because it's just in one region. So this is better than a local copy. I now had redundancy in the region, but it's not great. I can also then have GRS, which is the geo redundant. So now I have multiple copies in multiple regions. So I can have a secondary region. So if in this case Europe were to go down and the 3 copies there are no longer accessible, I could have it in another region. Okay. So typically it's read-only in those other ones. So that would be an RA, a read-only, a read access, GRS, very popular to put those two together. But Microsoft will initiate the failure for you. So why do we want to have this as a read-only access or read access? Because we don't want to have the capability of writing to, or they don't give us the capability to write into more than one spot at a time. So what happens is if Europe in my previous example were to go down and we fail over to North America, then they would make sure that the copies were up to date. They're doing the replication in the background. That's part of the GRS service, the geo-redundant component tree. And then they would make Europe read-only if that were to come up or be accessible, but they would make the writable copy in North America. So now we combine those, and as I've already mentioned, the read-only access, I already just kind of covered that one, so I'm going to skip that one for now. All right, let's talk about, I threw this one in just because the networking is kind of fun. And there's some things that a lot of people don't see and know about in networking. But then we've got like the bane of my existence, which is Azure Backup. And I say it's a bane of my existence because it's a pain, right? No one ever wakes up in the morning and says, I'm going to configure backup today. What a fun day. It's really not what you live for and what is fun. So let's talk about Azure Backup. I would recommend that you look into this and do some testing before. So you need to understand the rules of engagement for this. You are not going to back up on site, right? It's got unlimited scalability. There's a lot of automatic management, but you kind of got to play with it, especially if we incorporate the next couple of slides in ARS. You've got a lot of different options for it. I think I've already mentioned it's everywhere the data is encrypted. Azure is really good about data encryption. You can have long-term retention. There is a cost to that, right? So the longer you want to keep your backups, the more you're going to pay for that. You can be geo-redundant on the storage because the storage is storage. So go back to the storage topic, and you can have the GRS and have that completely redundant, right? So as I already mentioned, you're not going to back up on site. You're going to back up what's in the cloud, what's in the Azure cloud. So that's something to keep in mind. Sometimes customers think, well, I'll just have, sorry, I hit myself on mute. A lot of times customers think, well, I'm going to back up everything with this. It's going to back up, it's Azure Backup, it's going to back up Azure. So what do we have here? What's some of the key terminology, right? So there is a backup agent that can be deployed and can be deployed automatically for you. So you have the backup frequency, and these are some of the rules. I'm not going to read all of this to you or go over all this because it's kind of a busy slide, but you can have how frequent do you back up things, and you have retention options. You have how many recovery points do you have for a protected instance, and you can see there's a lot of those. How long do you keep things for? So that depends on how often you do your backup. Do you want to have, for DPM and for Azure Backup Server, how many application servers you're going to have? They have limitations to those. How many points on tape, right? So typically with DPM, it's unlimited. Okay, so again, Azure Virtual Machine Backups, it is snapshot aware, so you can use a VSS technology that you've probably used on site or with other Microsoft backup technologies that are available in Windows and have been for years. This is a native backup. It doesn't care about the operating system. It can be Windows, it can be Linux. When you're doing a VM backup, if it's an Azure VM, again, Windows or Linux, it doesn't really matter. It does not have a specific agent installation required because it's part of the infrastructure. When you have a VM in there, it's just part of the fabric. All right, so it's not an issue with doing all that. Okay. Limitations. So VMs can only be backed up once a day. They're restored at the disk level, cannot be on premise, as I've already mentioned, and it can be protected, and you can use everything with PowerShell, as you can imagine. Okay, so let's combine that backup technology with the site recovery or ASR. So Azure Site Recovery is what we're trying to get at is Europe goes down. Forget the storage level recover. We're trying to get all our applications and everything back up. We're trying to have a recover from a data center outage. Okay. So we're trying to protect the environment. It doesn't matter what the environment is, right? This will work with ASR. ASR works with Hyper-V, with VMware, with physical servers, right? So we can do a full site recovery of all this. It's the only one certified if we're going to do anything with the Microsoft technology like SharePoint or the messaging, Exchange, Dynamics. There's a whole bunch of things that are included in there. You can run DR drills, right? And do what ifs and not have a business or application impact or outage, which is kind of nice. And you can minimize things when you're looking at your round trip or your round recovery time and trying to get everything back. Supported platforms are all the regional VMs, VMware, like I mentioned, Skivum, which is a System Center virtual machine manager, the new System Center, anything with System Center in there, Hyper-V, physical servers, that whole process. So what we have here is we've got our data center on site. We're going to back that up to the cloud with ASR, right? So Azure Backup cannot do on-premise, but Azure Site Recovery, keyword is site there, will find whatever we hit it, and you're going to hit the Site Recovery Vault, a secure environment inside of Azure Cloud that is going to store our backup information and allow us then to, depending on where the Site Recovery Vault is and where it's replicated to, recover to different data centers possibly around the world and even back, of course, on premise. So we could be in North America, we do an ASR Site Recovery and put it up to the Azure Site Recovery Vault, and then maybe we need to restore in Japan. Right, we've lost North America. That data center's gone down. There's a power outage. The grid's down. We can now restore back to Japan using what's backed up in the cloud for that. So there's a lot of configuration that can happen in there. We got a processing server, configure server. We've got the target. In this case, would be Japan. We've got the mobility service. We've got a lot of different working components here inside of ASR. But I want to give you that in a nutshell. So we can do all kinds of things like a forced disaster recovery, a test failover. We can schedule these things to go back and forth, a failover and a fail back, which is to come back. We can also use ASR for, which is one of the things that a lot of customers use it for because of the cost. They don't necessarily want to back up their whole entire on-premise data centers to the cloud. It really depends on your business model and continuity. Migration. Right, so we're moving from one data center location to another. We can back it up to the cloud and then restore it in the new data center. So maybe we've outgrown our data center, the power requirements, maybe something's going on, there's been a flood, the data center is just not viable anymore, or we want to move out of that state to a different location because of our business model. So we can use ASR for migration. That is a very, very popular way of using ASR, okay? So we can, and we don't have to restore the whole data center, right? I've been talking about data center recovery, but we can do componentries of that. Okay. All right. Our last slide. Azure Data Protection. So now we're combining the backup services and ASR. So it's a combination of those things for the Microsoft Virtual Data Center deployment, right? So we've got the Azure Backup Agent or MARS, the Microsoft Azure Backup Agent. We've got the backup server. We got infrastructure as a service, VM backups. All those things can be part of the Azure Backup Service. And then I've already mentioned the Azure Site Recovery for on-premise or data center to go from one data center to another, to go from region to region. That's another good reason I forgot to mention that. That's another good use of ASR is maybe you need to move regions. Maybe you're closing down your European branch and you're going to move that to Asia, right? So we can do an ASR site recovery from Europe to Asia and never have to bring it back down, make tapes, and do all the kind of fun things, right? We can send it right from cloud to cloud and use it that way. All right, so my hour is up. I am going to stop presenting and be here for any questions and the raffle giveaway and all that fun stuff.
Awesome. Thank you, Rodney. I don't see any other question than the one that John asked. It was asked by Scott. So with that, if there is any question or anything that you would like to discuss with Rodney, please feel free to unmute yourself and you can talk to Rodney now.
Anybody still awake, or did I lose everybody? That was a lot to unpack, I know, but
it was a great presentation. So Thomas is still here. So
thanks, Thomas. Thanks for throwing me a bone.
All right, if there is nothing, then on behalf of the user group, I would like to thank you once again, Rodney, for taking time out and presenting. The topic you picked up was huge, and you did a great job in presenting within 1 hour. So that was great. And thanks once again, Sojeti, for sponsoring the user group meeting.